Okay, so starting with the orange paper. All right, so whenever we're going to use graphing to find our solutions, or our solution for the system, they must be in the y equals mx plus b form. Okay, whenever we're going to use substitution, we would have one equation that would be in your standard form, and then you would have y equals or x equals something. And then for the elimination, it would be both equations in standard form. Okay, any questions over that? Can we all recognize like the forms when they're set up in the equation? Yeah? How do we know when it's in standard form? Thank you. Both variables are on the same side, okay? And then the substitution, we notice that one of them is what? One of them is like solved for, right? Okay. And the other one is where they both are solved for. Okay. All right, so let's go to method madness here. Okay, so some of these I'm going to do with you, and then some of them you're going to be left to do on your own. So looking at number 1, we have x minus 3y equals 6 and x minus 3y equals negative 3. So what form are those equations in? They're in standard, so which method would we use? Elimination. So, or they're going to also refer to it as the linear combination, so we have to put LC. LC for method, and our reason was both equations are in standard form, so it would be E for the reason. So this one's giving us our methods, this one's giving us our reasons. All right, so going on to number 2. Substitution, and why do we say substitution? All right, so we have one in standard form and one where y is solved for, right? So we said our method was substitution, and we have one equation is already solved for y, so we'll put B. Okay, let's go to number 6. Graphing. So our method will be GT. And the reason is why. Both the equations are already solved for y, so it's in that slope-intercept form, so C. Any questions so far? All right, let's go down to number 7. So this one's a little bit different. Why are they different? Why are they different, Nicholas? Are you trying to log in still? Pay attention to this. I'll help you log into the other stuff. Why is this one different? Right, so both of them are solved for x, right? So what do y'all think you're supposed to do? What method do you think would be the best method? Well, if we did graphing, we would be backwards, right, on our x and y values. Because our x value has to be the input and our y value has to be the output. What were you saying, Ariana? What did you say? Substitution. Substitution would be our method here. And it's going to be because both equations are already solved for x, so D. Okay, can we flip over to the back side? Let's look at this one right here. So what is going to be our method? It's going to be the linear combination of the elimination method. So we'll put LC up here. And the reason being is because they are what?
The same side.
Well, what form are they in? They're both in standard form. Okay, so now we would have to go through our steps for using the linear combination. So first we have to determine if our terms are lined up. Are they lined up with x on top of x and y on top of y? Yes. Okay, so next I need to identify a zero pair. Do I have a zero pair? I do not have a zero pair. Which one would be the easiest to eliminate, the x or the y? Most definitely the x, because if I use the y, I would have to multiply something to the top and the bottom, because there's nothing I can multiply to this 5, right, to get 8, and nothing I can multiply to 8 to get to 5. But I can multiply what to either the top or bottom equation? -1. So where do you want to distribute the -1? To the top or the bottom? To the top? So we have to multiply everything by -1. So we'll distribute it to everything inside the parentheses. And then I'm just going to rewrite it under here. So we end up with -2x minus 8y equals -36. So now we have our zero pair here, and we can combine everything else. So -5y plus -8y gives me what? -13y. And that equals, what's -3 plus -36? -39. Okay, so now to solve, we do what?
Divide by -13.
Right, we're going to divide everything by -13. So we get that y equals 3. So now we have one of our variables solved for, and we have to solve the other one. So we can choose either equation, right? But either of the original equations. So which one do y'all want to use, the top or the bottom? The bottom? Okay. So we're going to use the 2x minus 5y equals -3. So this y we're going to replace with what? With 3. So when we do that, we get 2x minus 5 times 3 equals -3. So we have to distribute our 5. So that gives us 2x minus what? 15 equals -3. So now we need to isolate the 2x. So we'll add 15 to both sides. So that gives us 2x equals, what's -3 plus 15? 12. And now we just need to do what? Divide everything by 2. So x equals 6. Okay, and the last thing we want to do is what? We want to check and make sure that we have the correct solution. So this time, since we used this bottom one to come up with our x, or define our x value, we're going to use the top one to check it. So I would have 2 times what? 6 plus 8 times 3. And that is hopefully going to come out to be 36. So 2 times 6 gives me what? 12 plus 8 times 3, 24. And 12 plus 24 is 36. So we have the correct solution. So our solution is 6, 3. Any questions over that? No? Okay. All right, so one more. Number 10. It says Desiree borrowed $50 from her sister and plans to repay her $2 each week. At the same time, Desiree started earning $10 per week babysitting her younger siblings. Set up the system of equations that represent this situation. All right, so in the first part it says she borrowed $50 from her sister and plans to repay her how much each week? $2 each week, right? So that means X has to represent what? Perfect, the number of weeks. And then Y is going to be our total, right?
10 per week.
It's going to be our, yeah, it's going to be our total. What was it? Nothing? All right. Okay, so when we set it up, we would have Y equals, what was the starting point? 50? Are we going to be adding the 2x or subtracting the 2x? We got to subtract it because she's paying it back, right? So that's one of our equations. So the other part would be where Desiree started earning $10 per week babysitting her younger siblings. So again, we're going to have Y equals, right, for our total. And then what will be the rest of the equation? 10x, because it's going to be 10 times the number of weeks. Now we need to find out when the money she owes and the money she earns will be the same. So we're looking for what? The X or the Y value?
Y. X.
The X, because it's talking about when, like a timeline, correct? Yeah? You understand that? Okay. So what method would we use here? Let's graph it then. Everybody has their calculator? Hopefully. And we're using graphing because both of them are solved for Y. So we'd have 50 minus 2x for Y1, and Y2 is going to be 10x. And what are we looking for on the graph? The point where they intersect. Is it showing me on this one? It's not. We might have to make our window bigger. I'm going to do 0 here and then 100, 0. There we go. Now we can see where it intersects. Do y'all remember what to do to look at the point of intersection? Yeah, so second, trace, and then we hit 5 for intersect, and then enter 3 times. So at how many weeks?
4.
At 4. So our answer is going to be A. All right, any questions? No? Okay, so y'all just need to complete the rest of them. You have, let's see, 3 here on the back side, and then 1, 2, 3, 4, 5, 6, 7 on the front side.